are types of mechanoreceptors in glabrous or hairless skin. These include Meissner's corpuscles, Merkel disks, Pacinian corpuscles, and Ruffini endings. These receptors differ in location, size, innervation, adaptation, and the types of stimulus they're sensitive to. In terms of location, mechanoreceptors can be located in the dermis of the skin or the epidermis. Receptors located in the dermis of the skin are characterized as deep receptors. These include Pacinian corpuscles and Ruffini endings. Mechanoreceptors located in the epidermis of the skin are characterized as surface receptors, and these include Merkel disks and Meissner's corpuscles. Mechanoreceptors can also be characterized based on adaptation properties, which are sorted into two groups, slow adapting or rapid adapting. Slow adapting receptors are sensitive to stimulus as long as the stimulus is applied. Rapid adapting receptors are sensitive to the onset and offset of stimuli. Our focus during this presentation will be on Merkel disks and why they're important. Merkel disks are classified as slow adapting type 1 receptors. The structure of the Merkel disk includes a fluid-filled capsule that surrounds the sensory endings of the Merkel disk. Specifically, the receptors contain a protein linkage that's sensitive to stretch. This is known as a stretch-sensitive ion channel. When a deformation in the skin occurs, this protein linkage is stretched, opening the ion channels and allowing an influx of sodium-calcium into the membrane. This influx depolarizes the receptor, causing an action potential to fire. A larger stimulus will result in a greater action potential, leading to an increased release of neurotransmitters. The first step to a Merkel disk firing an action potential is physical stimulus. Because Merkel disks are specifically receptive to fine forms and edges, our example will be reading Braille. When an action potential is fired, sensory feedback is carried through first-order sensory afferent neurons towards the dorsal horn of the spinal cord. The sensory affect enters the dorsal horn and synapses with the neurons that extend into the dorsal column. More specifically, in this case of reading Braille, it will enter the cuneate fascicle. Sensory neurons from the cuneate fascicle travel upwards in the dorsal column until it synapses with second-order neurons within the inferior medulla at the cuneate nucleus. Within the inferior medulla, second-order sensory neuron decussates from the ipsilateral to the contralateral side of the spinal cord. At the superior medulla, the second-order neuron travels upwards through the structures of the brainstem, pons, and midbrain. These second-order neurons will synapse with third-order neurons, specifically the ventral posterior lateral nucleus. The third-order neurons synapse with a white matter tract called the internal capsule, carrying sensory feedback towards the primary somatosensory cortex. Most sensory feedback from Merkel disks enter area 3B for cortical processing. This information is integrated with sensory information from other receptors that detect touch and proprioception at area 2. All information from area 2 is processed and sent to the anterior parietal cortex, area 5, and then towards the primary motor cortex, M1, and premotor areas. Now that we know more about the characteristics and pathways of Merkel disks, we can relate this to the sporting world as well as daily life. For instance, in basketball, Merkel disks are crucial for detecting the pebbles on a basketball to get a feel for and have better control over maneuvering the ball. Merkel disks are also important to sports such as rock climbing. It is important to have a sense of whether a surface is safe to grab onto. The high tactile acuity and detection of fine forms by Merkel disks help facilitate rock climbing, since they can detect if a surface has fine edges that will make the climb easier or safer. Merkel disks are clearly important for everyday life, but you can lose Merkel disks, and thus tactile acuity, if skin is burned, or through chemotherapy, diabetes, or certain inflammatory diseases. Recreational drugs that affect serotonin can cause exaggerated tactile sensations. In conclusion, Merkel disks play an important proprioceptive role in our everyday lives as well as in sport. Thank you for watching.
Created using Powtoon.